Welcome back to the physics class, dear students. So that in the previous class we started with the numericals, right? As I said you before, just place a calculator, a logbook and also your book with you. So just it's easier for you to solve it. Dear students, here I am just going to read out the question. So when I will read the question, pause the video and write the question first. After writing it, so just while I am just going to write the given values, observe the question carefully. So my dear students, now we are starting with the next numerical. There in the last class we discussed only the two numericals. So now I am moving with the numerical number 3. That is what third numerical I am discussing here. So that in this chapter, the theory is also much important as well as the numericals also plays a very much important role. Now I am moving with the first question, the third question. So I am just reading out the question. So first take down the question carefully just by pausing the video. A tank is filled with water to a height of 12.5 centimeter. Full stop. The apparent depth of a needle lying at the bottom of a tank is measured by the microscope to be 9.4 centimeter. Full stop. What is the refractive index of water? Question mark. If water is replaced by a liquid of refractive index of 1.63 up to the same height, by what distance would the microscope have to be moved to focus on the needle again? Dear students, in the last class I just solved the numericals which are exactly based on the prism, that is what angle of deviation and also angle of prism. But now in this class we are just moving towards the discussion of apparent depth and real depth. Hope you all pause the video and you written the question. Now I will just move on of writing of the given values. Given values na baritirira. So I am just going to come on this. So I want to have a complete about to solve. So my dear students, hope you all written the question. So let us write the given values. A tank is filled with a water to a height of 12.5 centimeter. So we have a tank. So that tank is completely filled with water. So that tank is filled with the water up to a height of 12.5 centimeter. So what is that? Because it is a real depth. So that the real depth is equal to 12.5 centimeter. 12.5 centimeter. Real depth is 12.5 centimeter. Then next it was continued. The apparent depth of a needle lying at the bottom of the tank, which is measured by a microscope to be 9.4 centimeter. Obviously, my dear students, here what does it? This that they placed a needle inside the tank, whereas the apparent depth of the needle which was measured by the microscope. And that microscope in a measure the distance is apparent distance of needle 9.4 centimeter, which is equal to 9.4 centimeter. Full stop. What is the refractive index of water? What we should calculate? Refractive index of water, that is NW is equal to question mark. Next. Still the question is continued. If the water is replaced by liquid of refractive index 1.63 up to the same height. See my dear students, our ಏನು ಹೇಳಿದ್ದಾರೆ ಅಂದ್ರೆ what they given. See ಇಲ್ಲಿ water ನ 12.5 cm ಅಷ್ಟು ಟ್ಯಾಂಕ್ ಅಲ್ಲಿ ಫಿಲ್ ಮಾಡಿದ್ರು. Now ಈ ವಾಟರ್ ನ ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಈ ವಾಟರ್ ಇಸ್ ರಿಪ್ಲೇಸ್ಡ್ ಬೈ ಲಿಕ್ವಿಡ್. ಹಾಗಾದ್ರೆ ಆ ಲಿಕ್ವಿಡ್ ನ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ? 1.63. Yes, 1.63 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. But for this case also real depth is same. See, here we have the two cases. One case is with water and the other case is with liquid. So first water na fill ಮಾಡ್ತೀವಿ, next we are filling it with the liquid of refractive index 1.63. Then what is the real depth for this case? It is same because what I ಹೇಳಿದ್ದಾರೆ as it was filled in case of water ಅಂತ ಹೇಳಿದ್ದಾರೆ. So it is 12.5 centimeter. Then what is the apparent depth that we should calculate? Put the question mark. Apparent depth we should calculate. And again the question is, by what distance would this microscope have to be moved to focus on the needle again? ಸೊ ಮಾಡಿಯ ಸ್ಟೂಡೆಂಟ್ಸ್ ಸೊ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ನಾವೇನು ಮೈಕ್ರೋಸ್ಕೋಪ್ನ ಮೂವ್ ಮಾಡಬೇಕು ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಸಿ these are what the given values. Yes, these are the given values. See, actually here the question was like this. So ನಮ್ಮ ಹತ್ರ ಒಂದು ಟ್ಯಾಂಕ್ ಇರುತ್ತೆ. So that I'm just going to write the tank over here. Yes. Here the tank is completely filled with water. At the bottom of this tank, see what is it? So this is filled with an height of 12.5 centimeter, which is called as real depth. Right. Now, at the bottom of this tank, we are going to place a needle. So you have a needle there, right? So you know that the ray of light is now traveling from denser medium to rarer medium. At this position, I am going to draw the normal. Right, I am going to draw the normal. Whereas the light ray is just going to refract from this position. So here the incident backfire, so it refracts. It refracts. Right, refract agata. So refract agata. Denser to rarer means it bends away from the normal. So ray of light is coming from denser to rarer medium. It bends away from the normal, so that ಈ ರೇನ ನಾನು ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡಿಕೊಂಡ್ರೆ ಸೊ ನನಗೆ ಯಾವ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಕಾಣುತ್ತೆ ಆಬ್ಜೆಕ್ಟ್ ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ನೀಡಲ್ ಇರೋ ತರ ಕಾಣುತ್ತೆ. ದಟ್ ಈಸ್ ವಾಟ್ ದಿಸ್ ಡಿಸ್ಟೆನ್ಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಅಪಾರೆಂಟ್ ಡಿಸ್ಟೆನ್ಸ್. ರೈಟ್. ವರಾಸ್ ಇದನ್ನ ವಿತ್ ದ ಹೆಲ್ಪ್ ಆಫ್ ಮೈಕ್ರೋಸ್ಕೋಪ್ ಇದನ್ನ ನಾನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ವಿತ್ ದ ಹೆಲ್ಪ್ ಆಫ್ ಮೈಕ್ರೋಸ್ಕೋಪ್ ಐ ಆಮ್ ಅಬ್ಸರ್ವಿಂಗ್ ದಿಸ್. So with the help of microscope, so I am just going to write the microscope over here, so that with the help of microscope we are observing it. With the help of microscope we are observing it. So but at first it was filled with water. So water na fill madana microscope ಈ ತರ ಇರುತ್ತೆ. Suppose if I fill this with a liquid of refractive index 1.63 ಅಂದ್ರೆ ಈ ವಾಟರ್ನ ತೆಗೆದುಬಿಟ್ಟು ಲಿಕ್ವಿಡ್ ನ ಫಿಲ್ ಮಾಡಿದ್ರೆ ಹಾಗೇನಾಗುತ್ತೆ, ಅಪಾರೆಂಟ್ ಡೆಪ್ತ್ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಯಾಕೆ? ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಆಫ್ ವಾಟರ್ ನಮಗೆ ಗೊತ್ತಿದೆ 1.3. ಈಗ ಅವ್ರು ಕೊಟ್ಟರೆ ಲಿಕ್ವಿಡ್ ಅಷ್ಟು 1.6 ಅಂದ್ರೆ ವಾಟರ್ ಗಿನ್ನ ಲಿಕ್ವಿಡ್ ಏನಾಗುತ್ತೆ, ಡೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಡೆನ್ಸಿಟಿ ಏನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಸೊ ಡೆನ್ಸಿಟಿ ಆಫ್ ದ ಲಿಕ್ವಿಡ್ ಇಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ ದ ಡೆನ್ಸಿಟಿ ಆಫ್ ವಾಟರ್. ಸೊ ಹಾಗಾದ್ರೆ ನಿಮಗೆ ರಿಫ್ರಾಕ್ಷನ್ is more, right? So by the time ನಿಮಗೆ apparent depth ಏನಾಗುತ್ತೆ, still it increases. ಏನಾಗುತ್ತೆ, ರೈಸ್ ಆಗುತ್ತೆ. ರೈಟ್. apparent depth increase ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ಅದನ್ನ ನಾವೇನು ಮಾಡ್ತೀವಿ, we used to calculate here. Here we are going to just calculate. So apparent depth calculate ಮಾಡೋದ್ರ ಜೊತೆಗೆ ಈ ಮೈಕ್ರೋಸ್ಕೋಪ್ ಏನು ಮಾಡ್ಬೇಕು ನಾವು, so we should change its position because ಇಲ್ಲಿರ್ತಕ್ಕಂಥ ವಾಟರ್ನ ಯೂಸ್ ಮಾಡಿ ಬಂದಿರತಕ್ಕಂಥ ಇಮೇಜ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಮೈಕ್ರೋಸ್ಕೋಪ್ನ ಪೊಸಿಷನ್ ಇರೋದು. ಸಪೋಸ್ ಇಲ್ಲಿ ವಾಟರ್ನ ರಿಮೂವ್ ಮಾಡಿ ಲಿಕ್ವಿಡ್ನ ಹಾಕೊಂಡಿದ್ವಿ, ಅರ್ಥ ಆಗ್ತದೆ ಅನ್ಸುತ್ತಾ? ಸೊ ಬೈ ದ ಟೈಮ್ ಏನಾಗುತ್ತೆ, ದ ಪೊಸಿಷನ್ ಆಫ್ ದ ನೀಡಲ್ ಚೇಂಜಸ್. ಅಂದ್ರೆ ಲಿಕ್ವಿಡ್ ಡೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ ಈ ಪೊಸಿಷನ್ ರೈಸ್ ಆಗುತ್ತೆ. ರೈಸ್ ಆದಾಗ ಅಪಾರೆಂಟ್ ಡೆಪ್ತ್ ಏನಾಯ್ತು, ಚೇಂಜ್ ಆಯ್ತು. ಸೊ ಹಾಗಾದ್ರೆ ಈ ನೀಡಲ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಲಿಕ್ಕೆ, ಲಿಕ್ವಿಡ್ನ ಬಂದಿರೋ ನೀಡಲ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಲಿಕ್ಕೆ ಮೈಕ್ರೋಸ್ಕೋಪ್ ಪೊಸಿಷನ್ ಚೇಂಜ್ ಮಾಡ್ತೀವಿ ನಾವು. ಹಾಗಾದ್ರೆ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಮೈಕ್ರೋಸ್ಕೋಪ್ ನ ಮೂವ್ ಮಾಡ್ತೀರಾ? ದಟ್ ವಾಸ್ ಅ ಕ್ವೆಶ್ಚನ್. ರೈಟ್, ದಟ್ ವಾಸ್ ಅ ಕ್ವೆಶ್ಚನ್. ಸೊ ಇಲ್ಲಿ ಮತ್ತೆ ನಾವು ಇನ್ನೊಂದು ಡಯಾಗ್ರಾಮ್ ಬರೆಯೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಸೊ ದಟ್ ಸಪೋಸ್ ಇಫ್ ಇಟ್ ಈಸ್ ರಿಪ್ಲೇಸ್ಡ್ ಬೈ ದ ಲಿಕ್ವಿಡ್, ಸೊ ಇದು NW ವಾಟರ್ ಇದ್ದಾಗ ಇರ್ತಕ್ಕಂಥ ಪೊಸಿಷನ್. ಮತ್ತೆ ಏನಾಗುತ್ತೆ, ಇಫ್ ಯು ಜಸ್ಟ್ ಯೂಸ್ ಅ ಲಿಕ್ವಿಡ್, ಸೊ ದ ಪೊಸಿಷನ್ ಚೇಂಜಸ್. ಸೊ ಹಾಗಾದ್ರೆ ವಾಟ್ ಇಸ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದಿಸ್ ಟೂ ಪೊಸಿಷನ್ಸ್ ಆಫ್ ಮೈಕ್ರೋಸ್ಕೋಪ್? ವಾಟರ್ನ ಯೂಸ್ ಮಾಡಿದಾಗ ಇರ್ತಕ್ಕಂಥ ಪೊಸಿಷನ್ ಅದು, ಲಿಕ್ವಿಡ್ನ ಯೂಸ್ ಮಾಡಿದಾಗ ಪೊಸಿಷನ್ ಎಷ್ಟಿತ್ತು, ಆ ಎರಡು ನ್ಯೂ ಪೊಸಿಷನ್ಸಿನ ಡಿಸ್ಟೆನ್ಸ್ ಏನು ಅದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ನಾವು. ವಾಟರ್ ತೆಗೆದು ಲಿಕ್ವಿಡ್ ಹಾಕಿದ್ರೆ ಅಪಾರೆಂಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಇಮೇಜ್ ಅಬ್ಸರ್ವ್ ಮಾಡಲಿಕ್ಕೆ ಮೈಕ್ರೋಸ್ಕೋಪ್ನ ಮೂವ್ ಮಾಡ್ತೀವಿ, ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಮೂವ್ ಮಾಡಿದ್ದೀವಿ ಅನ್ನೋದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. Dear students, you know the formula, that is what a refractive index N is equal to real depth divided by apparent depth. So that n is equal to real depth divided by apparent depth. So I want to calculate NW, right? So NW is equal to, what is real depth? 12.5 centimeter divided by apparent depth is 9.4 centimeter. My dear students, just by dividing it, that is what 12.5 divided by 9.4. So you got that always the refractive index of water is 1.33. It is not having SI unit because both real depth and apparent depth both are having same SI unit. They cancel with each other. Finally, you will get the refractive index of water is 1.33. So that we completed the first part of the question. Now I am just moving towards the calculation of apparent depth. 1. Water is replaced by liquid. So here water na remove ಮಾಡಿ liquid na place ಮಾಡಿದಾಗ apparent distance ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ liquid na position ಯಾವ ತರ ಚೇಂಜ್ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕು. So I am using the same formula n L ಅಂತ ಬರೀತೀನಿ, right? N is equal to real depth divided by apparent depth. ನನಗೆ ಏನು ಬೇಕು? I want to calculate apparent depth. So cross multiplication replace ಆಗುತ್ತೆ. So apparent depth is equal to real depth divided by refractive index of the liquid. What is real depth? 12.5 centimeter divided by refractive index is 1.63. So 12.5 divided by 1.63. Use your calculator and divide it. So 12.5 by 1.63 gives you 7.67 centimeter. 7.67 centimeter. Yes. This is the apparent depth of an object, of an image of a needle when water is replaced by liquid. See my dear students, ಗೊತ್ತಾಯ್ತು ಅನ್ಸುತ್ತಾ ನಿಮಗೆ? ನಾನು ಆಗಲೇ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಬೇಕಾದ್ರೆ ಹೇಳಿದೆ water is less denser than liquid. ಯಾಕೆ ಅಂದ್ರೆ refractive index of water is 1.33, liquid ನ refractive index 1.63. So again liquid is denser than water, again refraction ಜಾಸ್ತಿ ಆಗುತ್ತೆ. So ಇದು this is the image formed by the water ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, so ಹಾಗಾದ್ರೆ ಏನಾಗುತ್ತೆ, ಇನ್ ಕೇಸ್ ನೀವೇನಾದ್ರೂ ಲಿಕ್ವಿಡ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡ್ರೆ, ಸೊ ಲಿಕ್ವಿಡ್ ಫಿಲ್ ಮಾಡಿದಾಗ ಅದರ ಪೊಸಿಷನ್ ಎಲ್ಲಿರುತ್ತೆ? ಮೇಲಕ್ಕೆ ಹೋಗುತ್ತೆ. ಸೊ ಇಟ್ ಮೀನ್ಸ್ ಅಪಾರೆಂಟ್ ಡೆಪ್ತ್ ಏನಾಯ್ತು? ಇಲ್ಲಿ ರೆಡ್ಯೂಸ್ ಆಯ್ತು, ರೈಟ್? ಅಪಾರೆಂಟ್ ಡೆಪ್ತ್ ಏನಾಯ್ತು? ರೆಡ್ಯೂಸ್ ಆಯ್ತು ಫಾರ್ ಲಿಕ್ವಿಡ್. This is the apparent depth for water, whereas this is the apparent depth for liquid. Then ಅದಲ್ಲ. So see, apparent depth for water ಎಷ್ಟಾಯ್ತು? 9.4. they given already. Apparent depth for liquid ಎಷ್ಟಾಯ್ತು? we calculated it 7.67. ಹಾಗಾದ್ರೆ ಸೊ ಇಲ್ಲಿ apparent depth distance change ಆಗಿದೆ ಅಂದ್ರೆ obviously microscope ನ position ಕೂಡ change ಆಗುತ್ತೆ. So dear students, it is very easy if we just subtract the apparent depth that we got from the water by the apparent depth that we got from the liquid, so that avedala subtraction ಮಾಡಿದ್ರೆ ನಮಗೆ ಏನು ಬರುತ್ತೆ? will get the distance between the position of the microscope when we fill the tank with water and when we fill the tank with liquid. So let us do that. Write one line. The distance through which the microscope has to be moved. The distance through which the microscope has to be moved. Microscope has to be moved. Yes, move ಮಾಡಬೇಕು. So that is what? 9.4 minus 7.67. So 9.4 minus 7.67. So use your calculator. How much you will get? 9.4 minus 7.67. Do it yourself. How much you will get? You will get 1.7 centimeter. अगर ನೀವು microscope ना ಎಷ್ಟು ಮೂವ್ ಮಾಡಬೇಕು 1.7 ಸೆಂಟಿಮೀಟರ್ ಅಷ್ಟು ಮೂವ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. Yes, this is about the question number 3. Hope you got this, dear students. So now let us move with the next question. Yes. Okay, take down the next question. Take down the next question. So I'm just going to read out the next question. Yes. A beam of light converges at a point P, full stop. Now a lens is placed in the path of the convergent beam 12 cm from P, full stop. At what point does the beam converge if the lens is, question number A convex lens of focal length 20 cm, comma, and question number B, a concave lens of focal length 60 cm. Question mark. This was a question number 4. So hope you written the question. So you can observe that here they given the two sub questions. Actually in that we have one question with a convex lens and another with concave lens. Let us solve it clearly. So before going to solve, let us write the given values first. I am just going to write the given values. That is what we are solving out, the question number 4. Yes. So now I am just going to read the question and I am going to write it. A beam of light converges at a point P. See my dear students, to solve this, first we should write the diagram. Then we can move for the calculation. First diagram na bardu aamele given values na bariyona. Why? Because we have two parts, A and B. So first I am moving with part A. Okay, yes. Now the lens is placed in the path of convergent beam 12 cm from P. See, at what point does the beam converge if the lens is? See my dear students, ಈ question ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ ಆಲ್ರೆಡಿ ಒಂದು ಕಾನ್ವರ್ಜಿಂಗ್ ಬೀಮ್ ಅಂತಕ್ಕಂಥದ್ದು ಬೀಳ್ತಾ ಇದೆ ಅಂತ ಎಲ್ಲಿ ಪಾಯಿಂಟ್ ಪಿ ನಲ್ಲಿ. ಸೊ ಫಸ್ಟ್ ಕ್ವಶನ್ ಅಲ್ಲಿ ಏನು ಹೇಳಿದ್ದಾರೆ, ಅಲ್ಲಿ ಯಾವ ಲೆನ್ಸ್ ಇದೆ ಅಂತ ಏನು ಕ್ವಶನ್ ಇಲ್ಲ. ಸೊ ಫಸ್ಟ್ ನಾನೊಂದು ಪ್ರಿನ್ಸಿಪಲ್ ಆಕ್ಸಿಸ್ ತರ ಬರ್ಕೊಳ್ತೀನಿ. ಸೊ ದಿಸ್ ಪೊಸಿಷನ್, ಸೊ ಏನಾಗ್ತಾ ಇದೆ, ರೇಸ್ ಕಾನ್ವರ್ಜ್ ಆಗ್ತಿದೆ ಅಂತ. ಎಷ್ಟು ಎಲ್ಲಿ ಕಾನ್ವರ್ಜ್ ಆಗ್ತಿದೆ ಗೊತ್ತಿಲ್ಲ ನನಗೆ. ಸೊ ಬಟ್ ಈ ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್ ಇದೆಯಾ ಕಾನ್ಕೇವ್ ಲೆನ್ಸ್ ಇದೆ ಐ ಡೋಂಟ್ ನೋ. ಸೊ ಐ ವಿಲ್ ಜಸ್ಟ್ ವಾಟ್ ಐ ವಿಲ್ ಡು, ಇಲ್ಲಿ ರೇಸ್ ಏನಾಗ್ತಾ ಇದೆ ಕಾನ್ವರ್ಜ್ ಆಗ್ತದೆ. Converging at a point P. Yes, ಇಷ್ಟ ಕೊಟ್ಟಿರೋದು ಫಸ್ಟ್ ಫುಲ್ ಸ್ಟಾಪ್. Now the lens is placed in the path of convergent beam. ಅಂದ್ರೆ ಈ ಕಾನ್ವರ್ಜೆಂಟ್ ಬೀಮ್ ಪಾತ್ ಅಲ್ಲಿ ಅಂದ್ರೆ ರೇ ಏನಾಗ್ತದೆ ಕಾನ್ವರ್ಜ್ ಆಗ್ತದೆ. ಈ ಕಾನ್ವರ್ಜ್ ಆಗೋದ್ರಲ್ಲಿ ಈ ರೇಸ್ ನಲ್ಲಿ ಒಂದು ಲೆನ್ಸ್ ನ ಪ್ಲೇಸ್ ಮಾಡ್ತೀರಾ. ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಪ್ಲೇಸ್ ಅ ಲೆನ್ಸ್ at this converging beam. Converging beam ಅಂತ ಏನಿದೆ, converging beam ಅಂತ ಏನಿದೆ. ಸೊ ಈ converging beam ಅಂತ ನೀವು ಏನು ಮಾಡ್ತೀರಾ, you are going to bring a lens and you are going to place it. Good. So lens ನ place ಮಾಡ್ತಾರೆ. ಯಾವ ಲೆನ್ಸ್ ಅಂತ ಇನ್ನ ಹೇಳಿಲ್ಲ, place ಮಾಡೋಣ afterwards. We are placing a lens at 12 cm from P. ಅಂದ್ರೆ we are going to place a lens ಎಲ್ಲಿ from 12 cm from P. ಈ ಪಾಯಿಂಟ್ P ಇಂದ 12 cm ದೂರದಲ್ಲಿ we are going to place a lens. Lens na place ಮಾಡ್ತೀವಂತೆ. Yes, then if the lens, yes, at what point does the beam converge if the lens? See, ಹಾಗಾದ್ರೆ this is already a converging beam. ಇದಾಗಲೇ converging beam ಇದೆ. ಪಾಯಿಂಟ್ P ಹತ್ರ ಕಾನ್ವರ್ಜ್ ಆಗ್ತಿತ್ತು. ಕ್ವಶನ್ ಏನು ಹೇಳಿದ್ರು, ಈ ಕಾನ್ವರ್ಜಿಂಗ್ ಬೀಮ್ ಅಲ್ಲಿ 12 cm ದೂರದಲ್ಲಿ ನೀವೇನಾದ್ರೂ ತಗೊಂಡ್ಬಂದು ಲೆನ್ಸ್ ನ ಪ್ಲೇಸ್ ಮಾಡಿದ್ರೆ, ಸೊ ಹಾಗಾದ್ರೆ ಆ ಲೆನ್ಸ್ ಏನ್ ಮಾಡುತ್ತೆ, ಈ ಬೀಮ್ ನ ಮತ್ತೆ ಇಮೇಜ್ ಆಗಿ ಫಾರ್ಮೇಶನ್ ಮಾಡುತ್ತೆ. ಯು ನೋ ದಟ್ ಇಫ್ ಯು ಜಸ್ಟ್ ಪ್ಲೇಸ್ ಅ ಲೆನ್ಸ್ ಸೊ ದಟ್ ಇನ್ ಫ್ರಂಟ್ ಆಫ್ ಅನ್ ಆಬ್ಜೆಕ್ಟ್ ಇಟ್ ಫಾರ್ಮ್ಸ್ ಅನ್ ಇಮೇಜ್. ಸೊ ದಿಸ್ ಈಸ್ ವಾಟ್ ಕಾನ್ವರ್ಜೆಂಟ್ ಬೀಮ್. ಆಲ್ರೆಡಿ ಕಾನ್ವರ್ಜೆಂಟ್ ಬೀಮ್ ಇದೆ. ಸೊ ಹಾಗಾದ್ರೆ ಈ ಕಾನ್ವರ್ಜೆಂಟ್ ಬೀಮ್ ಹತ್ರ 12 cm ದೂರದಲ್ಲಿ ನೀವು ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ, ಯು ಜಸ್ಟ್ ಪ್ಲೇಸಿಂಗ್ ಅ ಲೆನ್ಸ್. Suppose first question ಅಲ್ಲಿ convex lens. So first question ಅಲ್ಲಿ convex lens ಅಂತ ಹೇಳಿದ್ದಾರೆ. So I am going to place a convex lens at a distance of 12 cm. Dear students, converge ಆಗ್ತಿದೆ. It means it may be the parallel beam. So the convex lens again is the optic center. The right optic center. See, from optic center, the distance between the optic center and the point P is called as the object distance u. ಇದನ್ನೇನಂತ ಕರಿತೀವಿ ಆಬ್ಜೆಕ್ಟ್. ಸೊ ಪಾಯಿಂಟ್ P ಅನ್ನೋದು ಯಾವ ತರ ಆಕ್ಟ್ ಆಗುತ್ತೆ ಲೆನ್ಸ್ಗೆ? ವರ್ಚುವಲ್ ಆಬ್ಜೆಕ್ಟ್ ಆಗಿ ಆಕ್ಟ್ ಆಗುತ್ತೆ. ಹಾಗಾದ್ರೆ ಈ ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್ ಇಮೇಜ್ ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತಿದೆ. ಆಫ್ಟರ್ ರಿಫ್ರಾಕ್ಷನ್ ಇಟ್ ಫಾರ್ಮ್ಸ್ an image. So this is the point of image formation. So ಹಾಗಾದ್ರೆ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಇಮೇಜ್ ಫಾರ್ಮೇಷನ್ ಆಗಿದೆ? That is what the distance between the image eye ಮತ್ತು optic center is called as the image distance V. This is the question. ಆಮೇಲೆ ಸೆಕೆಂಡ್ ಕ್ವೆಶ್ಚನ್ ಕೂಡ ಡಯಾಗ್ರಾಮ್ ಬರೆದು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡೋಣ. ಫಸ್ಟ್ ದಿಸ್ ಇಸ್ ವಾಟ್ ಪಾರ್ಟ್ A, ರೈಟ್? ಸೊ ಏನು ಹೇಳಿದ್ದಾರೆ? ಎ ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್ ಆಫ್ ಫೋಕಲ್ ಲೆಂತ್ 20 centimeter. See, they given that the object distance for question A, object distance is 12 centimeter. We should calculate the image distance B. Convex lens of focal length 20 centimeter. For convex lens, the focal length is always positive, so it is of plus 20 centimeter. So what we should calculate now? We should move for the calculation of B, image distance. So we know that we have the formula 1 by F is equal to 1 by V minus 1 by U. I want to calculate 1 by V, so that I am just writing this formula, rewriting this formula. 1 by V again ಕೊಡ್ತೀನಿ. Minus 1 by U ಈ ಕಡೆ shift ಮಾಡಿದ್ರೆ it becomes plus 1 by U. It becomes plus 1 by U. So ಏನಾಗುತ್ತೆ? 1 by F plus 1 by U. Right? Now 1 by V is equal to F is 20, U is 12 centimeter. Dear students, keep in your mind, P is a virtual object for convex lens. P is a virtual object for convex lens, and P is a virtual object for convex lens, and keep in your mind, I is the real image for convex lens. P ಏನಾದರೂ virtual object ಆಗಿ ಆಕ್ಟ್ ಆಗುತ್ತೆ. I ಅಂತಕ್ಕಂಥದ್ದು real image. Now let us do this one. So take out the LCM and solve it. So if you just solve it, so take the LCM and solve. So if you just take the LCM, so 20 ಮತ್ತೆ 12 ಇದೆ. So 20 ಮತ್ತೆ 12 ಗೆ hope you will get 60 as the LCM. So if you get that 60 as the LCM, so 60 means 20 3s are 60, 12 5s are 60. That is what 3 plus 5 is 8 divided by 60. Or else I want to be allowed, so take reciprocal, it becomes 60 by 8. Use your calculator, divide 60 by 8. How much you will get? I will just see, I am just writing it. You just use a calculator to calculate it. So you will get V is equal to 7.5 centimeter. It means when you place a convex lens of focal length 20 centimeter in the path of converging beam, which is of about 12 centimeter from the lens, it forms a real image at a distance of 7.5 centimeter from the optic center. So V is equal to 7.5 centimeter. This is about the first part of the question. Now the second part was like this. Here also the question, the first part of the question is same. That is what we must have to write line. So in which we have a converging beam of light. Here we have a converging beam of light. So I am just going to write the converging beam of light here. So whereas this converging beam of light is going to converge at the point P. So whereas exactly at 12 centimeter from the point P, we are going to place a concave lens here. So here the concave lens na place ಮಾಡ್ತಿದ್ದೀವಿ, right? Concave lens is placed here. So that P acts as a virtual object now. So after refraction, so it forms an image. It forms an image I at this position. Dear students, here the question is like this. Here the question is like this. You can observe that a concave lens of focal length 60 centimeter. Here the concave lens is with the focal length 60 centimeter. See your so the distance between the optic center and the image is called B. Whereas distance between the P and the optic center is considered as O. See, ನಾನು ಏನು ಮಾಡ್ತೀನಿ, ಕಾನ್ವರ್ಜಿಂಗ್ ಬೀಮ್ ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಸೊ ಇದೇ ಥರನೇ ಬರೀತೀನಿ ಇಲ್ಲೂ ಕೂಡ. ಸೊ ಸಾರಿ ಫಾರ್ ದ್ಯಾಟ್, ಪ್ಯಾನಲ್ ಬೀಮ್ ಬೇಡ, ಬಿಕಾಸ್ ಫೋಕಸ್ ಎಲ್ಲ ಹೋಗುತ್ತೆ ಅದು. ಅದಕ್ಕೆ ಕಾನ್ವರ್ಜಿಂಗ್ ಬೀಮ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ದಟ್ ಲೈಕ್ ದಿಸ್ ಇಸ್ ಮ್ಯಾಟರ್ ರೈಟ್, ಬಿಕಾಸ್ ನಾವು ಪ್ಯಾರಲಲ್ ಬೀಮ್ ಅಂತ ಬರೆದ್ರೆ ಫೋಕಸ್ ಎಲ್ಲ ಏನಾಗಬೇಕು ಮೀಟ್ ಆಗಬೇಕು. ಸೊ ಇಲ್ಲಿ ಕಾನ್ವರ್ಜಿಂಗ್ ಅಂತ ಹೇಳಿರೋದ್ರಿಂದ ಡೈರೆಕ್ಟ್ಲಿ ಕಾನ್ವರ್ಜಿಂಗ್ ಅಂತ ಬರೀತೀರಾ ರೈಟ್. ನೋ ಪ್ಯಾರಲಲ್ ಬೀಮ್, ನಥಿಂಗ್ ಆರ್ ದಿಸ್ ಗೋಯಿಂಗ್ ಟು ರೈಟ್. ಸೊ ಅಟ್ ದಿಸ್ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ನಾನು ಏನಾದರೂ ಕಾನ್ಕೇವ್ ಲೆನ್ಸ್ ನ ಪ್ಲೇಸ್ ಮಾಡಿದ್ರೆ ಎಸ್ ಎಲ್ಲಿ ಇಮೇಜ್ ಫಾರ್ಮೇಷನ್ ಆಗಿದೆ ಅಂತ ಕ್ವಶನ್. So let us write the given values. So what is object distance? It is equal to 12 centimeter. What is V? We should calculate. Question mark. Focal length is 16 centimeter. We know that already. For concave lens, always the focal length is negative. So that F is equal to minus 16 centimeter. And we know the formula. We know that the lens formula, that is 1 by F is equal to 1 by V minus 1 by U. I want to calculate 1 by V, so that if I am just going to shift, it becomes 1 by F plus 1 by U. Right. So here I am just substituting out the values. So 1 by V is equal to 1 by F is minus 16. So minus 1 by 16 plus 1 by 12. So my dear students, we have 16 and 12. What will be the LCM for 16 and 12? It is 48. So 48 is an LCM, right? Yes. Now you know that I am just taking out the LCM and I am calculating. So here it will come 16 and 3s up. So here we have minus, we minus that. So they get 48 and the 16 3s are 48. So minus is minus barithira next. 12 4s are 48. So 4 minus 3, it is plus 1 by 48. So 1 by V is equal to 1 by 48. It means V is equal to 48 centimeter. So we just completed the two parts of the question. Right. So one mark converging beam and the head, parallel beam just converging beam. This is about question number 4. Now let us move with the question number 5. Take down the next question, question number 5. The question number 5 was like this. So double convex lenses are to be manufactured from a glass of refractive index 1.5, with both faces of same radius of curvature. Full stop. What is the radius of curvature required if the focal length is to be 20 centimeter? Yes. Hope you written the question. Now let us write the given values first. Right. So here what they said? Double convex lens. It means we are just going to manufacture a convex lens. So that here they said the refractive index. They are going to prepare a convex lens with the help of a glass which is having a refractive index of 1.55. So write that n is equal to 1.55. Or simply you can write it as 1.5. Next, with both the faces of same radius of curvature. You know that concave lens and convex lens both are having two radius of curvature called as R1 and R2. So now here what they said, both the radius of curvature are same. So R1 is equal to R2. And what is that radius of curvature in the header? So R1 is equal to R2 is equal to question mark. Yes. Next question is continued. Observe the question. What is the radius of curvature? As we did already. So curvature required if the focal length is to be 20 centimeter. If the focal length is said to be for 20 centimeter. If the focal length is 20 centimeter, then what is its radius of curvature? Dear students, it's easy for you to calculate the radius of curvature if they given the focal length. But how and when? Yavag easy agutte radius of curvature calculate madodu. So yavag easy agutte andre it is only when they given the spherical surface. Spherical surface anta kottaga you know that capital R, that is radius of curvature, is equal to 2 times the focal length, that is 2f. So ee relation use ಮಾಡ್ಕೊಂಡು ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀರಾ. But here they given a convex lens. ಇಲ್ಲಿ ನಿಮಗೆ ಕೊಟ್ಟಿರತಕ್ಕಂತದೇನು ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. right? So then how to calculate the radius of curvature? Dear students, radius of curvature calculate ಮಾಡ್ತಕ್ಕಂಥದ್ದು it's very easy. You can calculate, but I will show the first part and also let us calculate the image distance also here. Now what I am just doing, so here what they said, the focal length f is equal to 20 centimeter. So focal length f is equal to 20 centimeter. ಇಲ್ಲಿ ಅವರು ಬೈ ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್ ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಸೊ ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್ ಗೆ ಫೋಕಲ್ ಲೆಂತ್ ಯಾವಾಗಲೂ ಕೂಡ ಏನಾಗಿರುತ್ತೆ, ಇಟ್ ಇಸ್ ಆಲ್ವೇಸ್ ಈಕ್ವಲ್ ಟು ಪಾಸಿಟಿವ್. Yes, here it is an easy thing to calculate. So as I said to you before, that the capital R is equal to 2 times of F. So R is equal to 2 times of F. So R becomes equal to 2 into 20. So 2 into 20 is 40. So then R1 and R2 both are equal to 40 centimeter. Because ಎರಡು ಸೈಡ್ radius of curvature same ಇದೆ ಅಂದ್ರೆ ಎರಡು ಕಡೆ focal length ಕೂಡ same ಇರುತ್ತೆ. That is obviously true. ಅದಕ್ಕೆ ನಾವು ಏನು ಮಾಡಿದ್ವಿ, R1 and R2 both are equal to 40 centimeter. So this completes your fifth question. Now let us move with the next numerical. Whereas this numerical is somewhat bit different. So now let us see and let us observe that how to calculate this, my dear students. Take down the question first. A small bulb is placed at the bottom of a tank containing a water to a depth of 80 centimeter. Full stop. What is the area of the surface of the water through which the light from the bulb can emerge out? Question mark. Refractive index of a water is 1.33. Consider the bulb to be the point source. See, now we are just moving towards the calculation of question number 6. Already we are going to place a small bulb inside the bottom of a tank. So first let us write the tank here. Right? I am just going to write the tank here. So whereas at the bottom of a tank they placed a point source. That is last again here, consider the bulb as a point source of light. Okay, we just place it a source. Whereas this tank is filled with the water. They given that the tank is filled with the water to a depth of 80 centimeter. So that what is the depth of the water in which the tank is filled? The depth of the water through which the tank is filled is 80 centimeter. I am just going to write the height so that the tank is completely filled with the water. The tank na water in the fill ಮಾಡಿದರೆ ಎಷ್ಟು height ಅಂತ ಹೇಳಿದ್ರೆ 80 centimeter ಅಂತ ಕೊಡ್ತಾರೆ. Yes. So what is the height to which the water is fed? So that the height is equal to 80 centimeter. Right. So ಇವಾಗ ಬರೋಣ. given values h is equal to 80 centimeter. Now observe it carefully. Point source denser medium ida. So the light ray is going to see, I am just going to write this as a normal. So as even you can call this as IH. Now the ray of light is going to travel from the denser medium to rarer medium with an angle of incidence greater than critical angle, say IC. See here the angle of incidence is greater than the critical angle IC. However, you know the relation that sin IC or sin C is equal to 1 by n. Sin C and the critical angle, IC and the critical angle, n and the refractive index. However, tan IC ಬರಿಬೇಕು. sin C ಅಂದ್ರೆ 1 by n. ಹಾಗಾದ್ರೆ tan C ನ ಯಾವ ತರ ಬರೀತೀರಾ? 1 divided by square root of n square minus 1. Just by using which one? Just by using, hope you are getting which one we are using here. We are using your mathematics to write this. So tan C can be written as, or tan IC can be written as 1 divided by square root of n square minus 1 is to 9. Next, see now ಏನಾಗುತ್ತೆ, ಇದು ಒಂದೇ ಸೈಡ್ ಅಲ್ಲ, to the both sides here we can observe the same, right? So at this position, so ಏನಾಗುತ್ತೆ, if the angle of incidence is greater than the angle of critical angle, so then it reflects back to the medium. If IC ನಲ್ಲಿ incident ಆಗ grazes the surface. It just grazes the surface. So that the critical angle ಅಲ್ಲಿ ಇನ್ಸಿಡೆಂಟ್ ಆಗ್ತಿದೆ ಅಂತ ಅಂದಾಗ critical angle ಅಲ್ಲಿ ಇನ್ಸಿಡೆಂಟ್ ಆಗ್ತಿದೆ ಅಂತ ಅಂದಾಗ ನಿಮಗೆ ಏನಾಗುತ್ತೆ? ಸೊ ದಟ್ ಇಟ್ ಜಸ್ಟ್ grazes the surface. ಸೊ ಬಟ್ ನಮಗೆ ಆಂಗಲ್ ಆಫ್ ರಿಫ್ರಾಕ್ಷನ್ ಚೇಂಜ್ ಇರುತ್ತೆ, ನಮಗೆ ಕಾಣುತ್ತೆ ಲೈಟ್ ರೇ. ಸೊ ಅದಕ್ಕೆ ಏನಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ? ಆಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್ ಗ್ರೇಟರ್ ದನ್ ಕ್ರಿಟಿಕಲ್ ಆಂಗಲ್ ಅಂತ ತಗೊಂಡಿದ್ದೀವಿ. ದೆನ್ ಇಲ್ಲೇನಿದೆ ನೋಡಿ, ಇಲ್ಲಿಂದ ನಮಗೆ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಒಂದು ಏರಿಯಾ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. ಅಂದ್ರೆ ಸೊ ಲೈಟ್ ರೇ ಈ ಥರ ಡೈವರ್ಜ್ ಆಗಿದೆ, ಈ ಥರ ಬಂದಿದೆ ಡೆನ್ಸರ್ ಮೀಡಿಯಂದ. ಎಷ್ಟು ಏರಿಯಾದಲ್ಲಿ ಆ ಲೈಟ್ ರೇ ಸ್ಪ್ರೆಡ್ ಆಗಿದೆ ಅನ್ನೋದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಸೊ ದಟ್ ಏರಿಯಾ ಎ ಇಸ್ ಈಕ್ವಲ್ ಟು ಕ್ವಶನ್ ಮಾರ್ಕ್. ಯು ನೋ ದ ಫಾರ್ಮುಲಾ ಫಾರ್ ಏರಿಯಾ ಎ ಇಸ್ ಈಕ್ವಲ್ ಟು ಪೈ ಆರ್ ಸ್ಕ್ವಯರ್. ಹಾಗಾದ್ರೆ ಫಸ್ಟ್ ಏನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು? ಆರ್, ದಟ್ ಇಸ್ ರೇಡಿಯಸ್. ಸೊ ಎಲ್ಲಿದೆ ರೇಡಿಯಸ್? ದಿಸ್ ಇಸ್ ದ ರೇಡಿಯಸ್ ಆರ್. This is the radius r. So let us give the name O, right? Yes, A. Let us give the name OSK or OAB. No problem. That OAB. That's better. OAB is better, right? Yes. My dear students, here is IC. So here I got that. Here also you can observe that e point allu kuda IC na agide. Nodi adannu bariyodilla. So just nimage gottiraಲಿ ಅಂತ ಹೇಳ್ತಾ. So this is what the diagram. We finally completed the diagram. Now let us move on for the calculation of area. That is equal to pi r square. First r ಬೇಕು ನಿಮಗೆ. Let us move for the calculation of r. So ಯಾವ ತರ r calculate ಮಾಡ್ತೀರಾ? Here I already written that tan c is equal to 1 by square root of n square minus 1. So ನಾವು sin c ಗೊತ್ತಿತ್ತು. With the help of sin c I written the formula for tan c. Right? But now ಏನು ಬೇಕು? ರೇಡಿಯಸ್ ಬೇಕಾಗಿರೋದ್ರಿಂದ ಕನ್ಸಿಡರ್ ದ ಟ್ರಯಾಂಗಲ್ OAB from the triangle OAB. So what is tan IC? Tan IC can be written as see my dear students. Now here it is in this way. This is 90 degree, right? So this is the hypotenuse, this is opposite, this is adjacent. So this is opposite, this is adjacent. Opposite is AB, adjacent is OB, right? So agar tan theta can be written as opposite by adjacent, that is AB by OB. Then what is AB here? It is R. What is OB here? It is H. But I want to calculate R. So cross multiplication by R is equal to H into tan IC. So R is equal to H into tan IC, right? So what is tan IC? It is square root 1 divided by square root of n square minus 1. So R is equal to H into 1 divided by square root of n square minus 1, right? So now R is equal to, what is H? So here it is 80 centimeter, 80 divided by, now square root of, what is refractive index of water? 1.5 square minus 1. 1.5 square minus 1. Because of water anta helidare, but they have not given the water anta helidare, they have not given the refractive index of water. We know that the refractive index of a water is 1.33 and the refractive index of a glass is 1.5. Water anta helidradrinda 1.3 whole square anta ಬರೆಯಬೇಕು. Take your calculator. First multiply 1.3 into 1.3 equals minus 1. Then apply square root. One value ಬರುತ್ತೆ, substitute ಮಾಡ್ತೀರಾ ಇಲ್ಲಿ. Then 80 divided by the value you got. So finally you will get that R is equal to 91.23 centimeter. 91.23 centimeter ಅಂತ ಬರುತ್ತೆ. I am going to convert it into meter. So centimeter ಅಂದ್ರೆ 91.2 into 10 to the power of centi means 10 to the power of minus 2 meter. Minus 2 ಅಂದ್ರೆ point ಏನಾಗುತ್ತೆ? 2 digits ಈ ಕಡೆ ಬರುತ್ತೆ. So R is equal to 0.91 meter. 0.91 meter. Yes. So you got the radius. Now let us move on for the calculation of area. So now area A is equal to pi r square. Pi means 3.4 into radius. R square is 0.91 into 0.91. Take your calculator. So just multiply this 3.414 into 0.91 into 0.91. You will get 2.61. 2.61. So what is the SI unit for area? SI unit for area is meter square. So that A is equal to 2.61 meter square. ಅಂದ್ರೆ ಅಷ್ಟು ಏರಿಯಾದಲ್ಲಿ ಲೈಟ್ ರೇ ಸ್ಪ್ರೆಡ್ ಆಗ್ತಾ ಇದೆ. ಬಲ್ಬ್ ಅನ್ನೋದು ಸೋರ್ಸ್ ಆಬ್ಜೆಕ್ಟ್ ಆಯ್ತು ಅಂದ್ರೆ ಅದನ್ನ ಟ್ಯಾಂಕ್ ಅಲ್ಲಿ ಪ್ಲೇಸ್ ಮಾಡಿದಾಗ 80 ಸೆಂಟಿಮೀಟರ್ ಅಲ್ಲಿ ಅದೇನ್ ಮಾಡುತ್ತೆ, ಲೈಟ್ ರೇನ ಸ್ಪ್ರೆಡ್ ಮಾಡುತ್ತೆ ಸರ್ಫೇಸಸ್ ಹತ್ರ. ಎಷ್ಟು ಏರಿಯಾದಲ್ಲಿ ಸ್ಪ್ರೆಡ್ ಮಾಡುತ್ತೆ ಅಂದ್ರೆ ದಟ್ ಈಸ್ ಆಫ್ ಅಬೌಟ್ 2.61 meter square. Okay, now let us move on the next question. Take down the next question, which is on exactly the combination of lenses. So take down the next question. So the question was like this: the focal length of convex lens is 0.15 meter. Full stop. A liquid lens is formed between a plane surface and one face of the lens. In bracket, radius is equal to 0.1 meter. Full stop. The converging combination shows a focal length of 0.3 meter. Calculate the focal length of liquid lens and the refractive index of the liquid. Dear students, here we should calculate the focal length, right? The focal length of a liquid lens and also the refractive index of a liquid. Let us calculate that. So my dear students, the refractive index of a liquid previous classes allo kuda neevu kaltidira just by applying the formula. That is what, just by using a formula which exactly relates you with that the focal length, radius of curvature and n. So direct agi calculate madidira. So now I am just not moving towards that calculation in this class, but I am just dealing with the calculation of the focal length of liquid lens. But another question, that is what refractive index antakantado, it is for your homework, but you can do it yourself. Yes. Now let us write the given values first. Here a focal length of a convex lens is 0.15 meter. So focal length of a convex lens is 0.15 meter. Yes, focal length FC. Then a liquid lens is formed between the plane surface and one face of a lens. See my dear students, here the question was like this. Here the question was like this. What they exactly given? What they exactly given? Already put the observe ಮಾಡಿ. ನಮ್ಮ ಹತ್ರ ಒಂದು convex lens ಇದೆ ಅಂತ. But this is said to be the convex lens. Yes. Whereas ಈ convex lens ಜೊತೆಗೆ ಮತ್ತೊಂದು liquid lens formation ಆಗ್ತಿದೆ ಅಂತ. ಯಾವ ತರ? Convex lens ಗೆ ಕಾಂಟ್ಯಾಕ್ಟ್ ಅಲ್ಲಿ. Then that liquid lens is formed between one plane surface and one curved surface of convex lens. ಇದು plane surface, ಇದು curved surface of convex lens. So ಇಲ್ಲಿ ಏನು ಮಾಡೋಣ? Let us fill it with water because we have a plain lens now, right? Water lens. It's a liquid lens. Yes. As finally we got two lenses. This is said to be the convex lens and this is said to be the liquid lens. Yes, this is said to be the liquid lens. Now let us do it once. So now, what is the focal length of liquid lens? FL is equal to question mark. Next it was continued, but they given that the radius is equal to 0.1 meter. What they given? The radius R is equal to 0.1 meter. It is what? The radius of this curved surface is equal to 0.1 meter. Next, the converging combination shows a focal length of 0.3 meter. Yes. So converging combination, it means the total focal length of the combination of the liquid lens and also the convex lens gives you 0.3 meter. Then finally calculate the refractive index of the liquid. NL is equal to question mark. So I will just give you this calculation of refractive index of the liquid as for your homework. Suppose if you not get the calculation, even I will discuss it in the next class. But now let us calculate the focal length of a liquid. Dear students, you know that from the combination of lenses, 1 by f can be written as 1 by f1 plus 1 by f2. But here we have one convex lens and another one is liquid lens. I want to calculate the focal length of liquid lens. So just replace the terms. So I am just replacing these two terms. What I will get? 1 by FL is equal to 1 by FC minus 1 by F. So now 1 by FL is equal to 1 by, what is FC? 0.15 meter minus 1 divided by F. F is 0.3. 0.3. Right. Dear students, first calculate the value of what is the value of 1 divided by 0.15. You can do it otherwise. So in FL it's difficult for us to calculate the LCM for 0.15 and 0.3. So you can convert this 15 by 100 and the 100 by 15. So 100 comes to the numerator and here 10 by 3. 10 by 3. So then you can move for the LCM and you can calculate it. So I will just show you that. It is 0.15 na 15 by 100 anta barindini. Just I will write it here. 1 divided by 15 by 100 minus 1 divided by 3 by 10. 100 moves to the numerator. That is what denominator for denominator is always numerator. That is what 100 divided by 15 minus 10 divided by 3. What's the LCM for 15 and 3? My dear students, obviously the LCM is 15 itself, right? Obviously the LCM is 15 itself. So, you can even just do it with the help of calculator, direct and ಮಾಡ್ಬೋದು. Or else suppose ನಿಮಗೆ ಸುಲಭ ಆಗಲಿಲ್ಲ ಮತ್ತೆ ಕನ್ವರ್ಷನ್ ಡಿಫಿಕಲ್ಟ್ ಆಯಿತು ಕನ್ವರ್ಷನ್ ಅಂದರೆ ಬೈ ದ ಟೈಮ್ ನೀವು ಈ ಥರ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೋಬೋದು. So what is LCM here? 15 is LCM. So numerator we have 100 minus 3 5 15 into 10 is 50. 50 by 15. That is 1 by FL. So reverse counter FL is equal to 15 divided by 50. So that you will get divide ಮಾಡ್ತೀರಾ. So you will get the value of the focal length of liquid. What will be the focal length of a liquid? Which is equal to value ಎಷ್ಟು ಬರುತ್ತೆ observe ಮಾಡಿ and substitute it, my dear students. So you will definitely get the value which is found to be equal to the -1. So negative value ಸಿಗುತ್ತೆ ನಿಮಗೆ. So you can check it once and you can even calculate it. Yes. So here they obviously given that the combination and also that the value of FC and FL. Suppose ಎರಡು ಕಾನ್ವೆಕ್ಸ್ ಅಂತ ಕೊಟ್ಟಿದ್ರೆ ಪ್ಲಸ್ ಅಂತ ತಗೊಂಡಿದ್ರೆ, ಎರಡು ಕಾನ್ಕೇವ್ ಕೊಟ್ಟಿದ್ರೆ ಮೈನಸ್ ಅಂತ ತಗೊಂತಾ ಇದ್ರೆ, ಒಂದು ಕಾನ್ವೆಕ್ಸ್ ಒಂದು ಕಾನ್ಕೇವ್ ಕೊಟ್ಟಿದ್ರೆ ಪ್ಲಸ್ ಅಂಡ್ ಮೈನಸ್ ತಗೊಂತಾ ಇದ್ರೆ, ಎರಡಕ್ಕೆ ಬಂದ ಲಿಕ್ವಿಡ್ ಅಂಡ್ ಕಾನ್ವೆಕ್ಸ್. ಸೊ ದಟ್ ವಿ ಜಸ್ಟ್ ಯೂಸ್ ಇಟ್ ಅಂಡ್ ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್. ಸೊ ಫೈನಲ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾದ್ರೆ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್. ಸೊ ರೈಟ್ ಒನ್ಸ್ ಇನ್ ಮೂವ್. So otherwise if it not possible, I will just solve you in the next class. Thank you dear students.